Okay, today we are going to look at some basic simplifying of radicals. Radical, if you remember, going back, I don't know, a couple chapters or whatever, radicals are numbers that are square root or cube root or fourth root or whatever. Those are radicals. In this case, we're only worried about square roots. We're not going to do any other funky root type things. And so here, the square root of 36. You guys know this, right? Square root of 36 is 6. And today, by the way, today we're only talking about what's called principal square roots, which are going to be positive. So typically we would write the square root of 36 as a plus or minus 36, right? Or plus or minus 6. Today, I'm only interested in that positive number. So the square root of 36 is 6. Now, here's the thing. We can rewrite 36 in a different way, can't we? Is it true that I could rewrite the square root of 36 as this 4 times 9?
Mm-hmm.
4 times 9 is 36, right? Okay. And then, so if I rewrote that as the square root of 4 times the square root of 9, I could also rewrite it this way. I could rewrite this, the square root of 4 times the square root of 9. Does that make sense?
Yeah.
What is the square root of 4?
2.
And what is the square root of 9?
3.
3. And what is 2 times 3?
6.
6. So, this lets us see how some things are going to work as we simplify. Now, I understand that this, what I just did here, this long drawn out thing, is not simpler than this, right?
Nope.
This was simpler. But sometimes we're going to get into numbers that don't have they're not perfect square numbers. And so we've got to break the numbers down to pull out some square roots so that we can simplify the entire expression. So for instance, the square root of 54. 54 is not a perfect square. So if I do square root of 54, it's going to be some weird decimal. Okay, which I don't want, because that involves rounding, which is not as accurate an answer as if we leave it in radical form. But it still can be simplified. And it can be simplified by doing this. 54 is what times what?
9 times 5.
9 times 6, maybe?
Yeah.
Yes.
Okay. Square root of 9 times 6. What is the square root of 9?
3.
3. So we can rewrite this as 3 times the square root of 6. That's the answer we're looking for. That is the simplified form of the square root of 54. Square root of 54 is the square root, or 3 times the square root of 6.
Oh my goodness.
Okay? So 80. Sometimes you might have to do a little bit of work to find the numbers that we need to get to that are perfect squares. What's a number that will go into 80?
8 and 10.
8 and 10 will go into 80. I'm not sure that helps us a whole lot because neither of those are perfect squares. How much?
5 and 16.
5 and 16. Okay, so 16 will go into 80. So this would be equals the square root of 16 times the square root of 5. All right. Huh? Say that again.
16 on the square root.
Yeah, 5 doesn't.
5, but that's okay. We want one of them to have a square root and the other one not. So the square root of 16 is 4 times the square root of 5.
Do both of them have a square root?
If both of them have a square root, then it's going to come out like your first one, like 36. They both had a square root, and so anytime you multiply two perfect square numbers, you're gonna end up with a number that has a square root anyway. Okay, so
9.
180.
We can put it in
You could put in. Okay, let's do that. Let's put in 9 times what?
20.
9 times 20, and so that gives us square root of 9 is
3.
times the square root of 20. But what about 20?
Who's up here?
20 is not, but it's got a perfect square in it.
10 and 16.
16 does not go into 20.
5 and 4.
It's 4.
5 and 4. So we can rewrite this as 3 times the square root of 4 times the square root of 5.
Wait.
I'm not done yet. What's the square root of 4?
2.
2.
3 times 2 times the square root of 5. What's 3 times 2?
6.
6 times the square root of 5. So this is simplified. Yes?
Why'd you pull out 4 and 5?
4 times 5 is 20.
Yeah, but why'd you choose 4 and 5?
Because 4 is a perfect square.
4 is a perfect square. If you use 2 and 10,
I see it now.
if you use 2 and 10, then you don't have a perfect square. Then this, holy smokes, I threw this one down here, and honestly, I haven't even worked this one out. I have no idea what we're gonna come up with here, but I know we're gonna come up with some perfect squares in there.
16.
Now, here's one that here's what we can do. And this may take a little bit of room, because I made it a big number on purpose. I can make it the square root of 2 times what? 1,240. Okay, now I can divide this by 2 again, can't I? So I can do that again. I can do 2 times 2 times 620. Now I can divide that one by 2 again, can't I? Okay, so 2 times 2 times 2 times 310. Now look what I can do. Another 2. You guys are going to hate this, but it works. 2 times 2 times 2 times 2 times
155.
155. Now, well, 2 won't go into this anymore, will it? Okay. But it will still break down. I don't know if it's got any perfect squares in it or not at this point. I'm not sure. So 25 won't go into it. 5 will go into it. So we can just keep breaking it down. 2 times 2. Oops, I forgot to do the times. 2 times 2 times 2 times 2 times 5 times 31. So that 31 is prime. Nothing will go into 31. So we have broken this down. We haven't done this all year. I don't think we did it in pre-algebra either, but this is called doing the prime factorization of a number. Okay? And so these are all prime numbers. Now all we have to do is figure out if there's any perfect squares here. 2 times 2 times 2 times 2 is what? 16. What's the square root of 16? 4. So we would have 4 times, we don't have any perfect squares with 5 and 31, so we can just leave it as 4 times the square root of 155. You're not going to have any this big on your assignment. I just wanted you to see this process of breaking a number down into its prime factors. Okay, just keep dividing it until you get it into numbers that won't divide anymore. Does that make sense?
Yes.
All right. The other thing that you're going to need to do is this is just kind of really starting one step along the way. Instead of having the square root of 75, I've given you the square root of 15 times the square root of 5. So there's 2 ways that you can do this. You can either multiply these. So 15 times 5 is 75. Now what square number is in 75? 25 times 3, right? So what's the square root of 25? So this would come out to 5 times the square root of 3. Or, I know I've got whatever number I end up with, I'm going to have to break it down into its smaller parts, right? So I can just do this. What 2 numbers are in 15? So I could just do square root of 5 times 3 times, and I can put them all under one radical, times 5. And anytime you end up with 2 numbers in the same radical, what's the square root of 5 squared? 5. And so you know that those 2 numbers just come to the outside and make 1. So it's just 5 times the square root of 3. All right. So I like this way better because it's already partly broken down for you. You just break it down the rest of the way and then find your numbers that'll factor. All right. So now if we're doing this, we've actually got numbers outside the radical, so we can just rewrite any multiplication. You can change the order, right? That's commutative property. So 3 times 5, and then I'm going to have 1 radical. Let's break 18 down. That's going to be, well, it's 2 times, there's only 1 2 in it, sorry. 2 times 3 times 3, right? Isn't that 18? 2 times 3 is 6, 6 times 3 is 18. Now let's break 14 down. 2 times 7. So look for pairs.
So 3 and 2.
Got a pair of 2s. So I'm going to move that to the outside. 3 times 5 times 2. I've got a pair of 3s. I'm going to move that to the outside. And then I'm going to leave inside what? Square root of 7. So 3 times 5 is 15, times 2 is 30, times 3 is 90. 90 times the square root of 7. All right, we'll do the same thing here. We've got a 2 and a 3 on the outside, so 2 times 3. And then inside we've got, what is 12? Break it down. 2 times 3, right? Times 7. We've got a 7 in the other radical. So I can pull out a 2. It's 2 times 3 on the outside, times 7, or square root of 7 in the middle, in the radical. 12 times the square root of 7. All right, this is just scratching the surface of simplifying radicals. This is all we're going to do on it this year. You're going to do more of it next year, I promise. And then I just wanted you to be exposed to it this year. So you got a short assignment of just simplifying some basic radicals like we've done in this lesson.
Do his thing.